Hello students, very good morning. Myself Ekarsha from New LGI Institute of Engineering and Technology. Today we are going to discuss Mathematics-1 with the topic total derivative and partial differentiation. So let's start the total derivative. If z is equal to f of u is a function of u and where u is a function of two variables x and y. Example, u is equal to phi of xy. Okay, it means here z depends on u and u is a function of two variables x and y. So we can represent the total derivative of z with respect to x as del z by del x is equal to, as z depends on one variable only, that is dz by du, into, and as del u by del x because the u is depends on two variables. It also represented as df by du into del u by del x. Similarly, we represent the total derivative of z with respect to y as del z by del y is equal to dz by du into del u by del y, or we represent df by du into del u by del y, right? And this rule is known as the chain rule. This rule is known as chain rule. Now, the composite function of one variable. Here, if u equal to f of xy is a function of two variables x and y. X is equal to phi t and y is equal to psi t. Then u is called function of one variable is composite function of t. See, in this case, u is depends on two variables x and y, and x and y both depends on one variable only, that is t, right? So here u is indirectly depends on the one variable, that is t. So we can represent here the derivative of u with respect to t as du by dt, as u depends on one variable t only, but the path is d del u. Here u depends on x and y, so we represent del u by del x into, as x depends on only one variable, that is dx by dt, plus del u by del y into dy by dt, right? So this is called the total derivative of u. It is called the total derivative of u, right? So let's start the example of the total derivative for the function 1 and the chain rule. Here our first question is, if u equal to y square minus 4ax, where x is equal to at square and y is equal to 2at, find du by d. Okay, so the solution is, here our given function is depends on u is depends on x and y, right? And x and y both depends on only one variable, that is t. Here a is constant and we want to find the du by dt, that is the total derivative, because u depends on x and y and x and y depends on only one variable, that is t. So as per the rule of the total derivative for the one function, that is du by dt is equal to del u by del x into dx by dt plus del u by del y into dy by dt. Now, first we want to find out the partial derivative of u with respect to x. Okay, and now our u is y square minus 4ax. So, del u by del x, that is the derivative of u with respect to x, that is minus 4a. And del u by del y, now the partial derivative of u with respect to y, that is 2y. Okay, and the derivative of x with respect to t, this is our x. So the derivative of x with respect to t is 2at, and the derivative of y with respect to t, here 2a, right? So dy by dt is equal to 2a. Now we are going to substitute all the four values in this equation 1. Now after substituting the all values in the equation 1, substituting all values in equation 1, we get that du by dx dt is equal to the value of del u by del x, that is minus 4a, into the dx by dt, that is 2a, plus the value of del u by del y, that is 2y, and the value of dy by dt, that is 2a, right? Now here the value of y is 2at. So we are substituting in the place of value of y. So after simplification here, minus 8 is square t plus 2, and the value of y is 280. So this is 280 into 2a, right? Now minus 8a square t plus 8a square t, and the final answer of the given example, that is 0. Okay, so let's move with one more example for the better understanding, that is u equal to x square plus y square plus z square, where x is equal to e raised to t, y is equal to e raised to t sin t, and z is equal to e raised to t cos t. Find du by dt. Okay, so this is our given question, and here our u is depends on x, y and z, and all three variables are depends on t. Okay, so let's start the solution. Here the partial total derivative rule, that is du by dt is equal to del u by del x into dx by dt plus del u by del y into dy by dt plus del u by del z into dz by dt. So we are going to now find out the partial derivative of u with respect to x, y and z first. Then we have to find the simple derivative of x, y and z with respect to t. So let's start the differentiation of u with respect to x, y and z, that is del u by del x. Here del u by del x is 2x, del u by del y, that is 2y, and del u by del z, that is 2z. Okay, now the derivative of x with respect to t. Here dx by dt, x is e raised to t, So the derivative of x with respect to t, that is itself only, here e raised to t. dy by dt. The y is here e raised to t into sin t. So now we are applying the multiplication rule. At that time the derivative of e raised to t is e raised to t. At that time sin t keep it same, plus e raised to t keep it same, and the derivative of sin t is cos t. The next one is dz by dt. Here z is e raised to t into cos t. So again we are applying the multiplication rule for the derivative, that is e raised to t cos t plus this one is e raised to t. The derivative of cos t is minus sin t. So here e raised to t cos t minus e raised to t sin t. Okay. Now we are going to substitute all these values in this equation 1. Okay. So substitute all values in equation 1. So du by dt is equal to the value of del u by del x, that is 2x, into dx by dt, and that is e raised to t. So 2x into e raised to t plus the value of del u by del y, that is 2y, and here e raised to t sin t plus e raised to t cos t, right? So 2y e raised to t sin t plus e raised to t cos t, and same 2z, here e raised to t cos t minus e raised to t sin t. Now the value of x is e raised to t, value of y is e raised to t sin t, and z is e raised to t cos t. So now we are substituting the value of x, y and z here. Substitute values of x, y and z. So 2 e raised to t into e raised to t plus 2 e raised to t sin t and e raised to t sin t plus e raised to t cos t plus 2, the value of z is e raised to t cos t, and in the bracket e raised to t cos t minus e raised to t sin t. So after simplification I have 2 e raised to 2t plus 2. If I get e raised to t common from this bracket, then I have e raised to 2t sin t, and this one is sin t plus cos t. Same, if I get e raised to t from the last bracket, that e raised to 2t cos t, and in the bracket the remaining term is cos t minus sin t. So if I get e raised to 2 e raised to t common, then 2 e raised to 2t common here, and the remaining term is 1 plus, after splitting this bracket, that is sin square t plus sin t cos t plus cos square t minus cos t sin t, as this term is plus and this one is minus, so both will be cancelled out, and here sin square t plus cos square t is always 1, so 1 plus 1 is 2, so 2 e raised to 2t, 1 plus 1, the final answer is 4 e raised to 2t. So this is the total derivative of the given function of u with respect to t. Okay. Now let's move to one more example, that is if z is equal to e raised to xy, x is equal to t cos t, and y is equal to t sin t, find dz by dt at t equal to pi by 2. If z is equal to e raised to xy, where x is equal to t cos t, y is equal to t sin t. We have to find dz by dt at t equal to pi by 2. So let's start the solution. Here our given function z is depends on two variables x and y, and x and y depends on one variable, that is t. So again we are applying total derivative rule, that is dz by dt is equal to del z by del x into dx by dt plus del z by del y into dy by dt. Okay, so here the partial derivative of z with respect to x and y is partially with respect to x and y. So first we have del z by del x, that is e raised to xy, as it is an exponential function, so e raised to xy keep remains same, into y. And similarly for del z by del y, that is e raised to xy into x. Now the ordinary derivative of z, x with respect to t, and then ordinary derivative of y with respect to t. For that, what x is here t cos t, t cos t. So dx by dt is, after applying the multiplication rule for the derivative, that is cos t plus t, the derivative of cos t is minus sin t. So here cos t minus t sin t. Same the derivative of y with respect to t, that is dy by dt. So here sin t plus t cos t. Okay, now I am going to substitute all these values in equation 1. This is our equation 1. So substitute all values in equation 1. So dz by dt is equal to the first value del z by del x, that is e raised to xy into y. Here e raised to xy into y, and the dx by dt, that is cos t minus t sin t. Here cos t minus t sin t plus the value of del z by del y, that is e raised to xy into x, the value of dy by dt, that is sin t plus t cos t. Okay, now I want to find the value of dz by dt at the point t equal to pi by 2, right? So dz by dt for t equal to pi by 2. First, if I put t equal to pi by 2, the value of x is, if I substitute t equal to pi by 2 here, then t is pi by 2. Cos pi by 2, as all know that cos pi by 2 is 0, so the value of x is 0, right? And if I take t equal to pi by 2 in the y, then this t is pi by 2 and sin pi by 2 is 1. So value of y is just pi by 2. So now I am substitute the value of x and y in this equation 2, because I want to find the value of dz by dt at t equal to pi by 2. So dz by dt and t equal to pi by 2 is equal to, here see this x is 0, so 0 into anything is 0, so e raised to 0 is 1, and this y is pi by 2, so 1 into pi by 2, the other bracket, cos pi by 2 is always 0, minus t pi by 2, and this one is sin pi by 2, that is 1, so 0 minus pi by 2 here, the bracket 0 minus pi by 2 plus here. If I substitute 0 in the place of x, and the 0 into anything is 0. So my next term will be 0. And after simplification, my final answer is minus pi square by 4. So this is the total derivative of z with respect to t, and t equal to pi by 2 for the given function. And my answer is minus pi square by